Welcome to Lesson 7 of Module 4. We're going to start with our do now. So define the word unify, and how do you think this word may apply to scientific theories? Our do now was important because we're looking at how theories and laws are used in science, so the same inquiry question that we looked at in our last video. But we're going to be looking at how diverse phenomena have been unified into specific theories. And here we can see it says, for example, so we only need to choose one from the list. So we're going to be looking at the theory of evolution. And our learning intention for today is to assess the importance of unifying diverse perspectives into one idea. So, again, we're just going back over a few things before we look at unifying. So, a scientific fact is an objective observation that is verifiable by repeatable observation and measurement. I remember that scientific theory seeks to explain why different events would have occurred. And throughout history, scientists have looked at how they could unify theories for different phenomena into one single theory that explains all of the different facts that are able to be seen. And we're going to be looking at the theory of evolution. So, a unifying theory is one that helps to explain a broad range of different observations. So, what might look like a singularity to one scientist, once these are taken into the scientific community, by unifying the theory, it allows all of these observations to be grouped under the one heading, like we can see here on the right. It allows the interpretation of many aspects of science on a grand scale and allows many unrelated phenomena, which, when they work in isolation, may seem unrelated. It actually allows them to make their relationship more clear, which we can see here with plate tectonics. On the right. So we can see here in the little pink here, it says, why is plate tectonics the unifying theory in geology? And looking at plate tectonics at the top, we can see here that all of the different convection, the way that plates move, the different ways that we see plate boundaries move, different phenomena like volcanoes and magma, and we can see the different types of rocks, and we can see this all collated into the theory of plate tectonics here. So the one that we're going to be looking is the theory of evolution. And so looking at ecology, inheritance, climate, geology, and biological processes, and how different aspects of all of this all unified to have what we now know as the theory of evolution. So I'm going to pause this here to watch this video on the different evidence for evolution. And then we can see here that the different phenomena we're going to see and the evidence we have here, we're going to perform a rigorous reading to deconstruct this bit of information. But remembering that diverse phenomena are unified into theories because the theory explains how things worked and how many events can be understood better once the unifying theory is in place. So the theory of evolution unifies principles from ecological changes in the environment, the inheritance of genes, the way the climate works and natural pressures, biological processes, and geological events, and how they all work together and are now unified under the theory of evolution. Again, using our, we're going to be working on the computer with our text. So looking for our main idea and our evidence here, using our rigorous reading annotation guide that we've got here, and the levels of questions that follow to further understand how the theory of evolution is in fact a unifying theory. There is no Google form for this lesson itself, but we will update our inquiry question log. So how are theories and laws used in science?